typically the easiest pathways through the shortest distance of an insulator. I'm just shortening up the distance of air between the cage and the machine, so there's no question this cage is in fact going to get struck by lightning. I'm really banking on the fact that metal might have something to do with why you're safe. Because if not, I'm in big trouble. So everybody cross your fingers, because we're going to get those motors started up. Make sure I'm absolutely, positively the tallest object here in the theater of electricity, and then I'm going to seat in the middle of my makeshift car, so we can now find out what happens when I strike this cage with over 1 million volts of electricity. Are you ready? Yeah. More importantly, am I ready? Headphones going on, fingers are crossed. There we go. Surrounded by conducting metal. It sounds crazy, but you folks, being the smart audience that you are, I'm sure that you knew that I knew I was actually going to be safe. Because this would be a terrible demonstration to try out for the first time in front of a live museum audience. But I knew I was going to be safe for an important reason. A lightning bolt is a little bit different than the electricity that comes from your wall outlets. With a lightning bolt, we have a very fast-moving, rapidly changing burst of energy. Because of that constant changing, those electric charges are getting pushed only to the outer skin of the metallic object, keeping me safe sitting in the middle, but even keeping me safe touching the inside surface of the bars. Had my hand slipped through the bars, had I held onto the bars, different story entirely. Now, we talked about these electric